Hey guys, in the last video I guided you through some limiting reactant practice problems, but in this video I'm going to have you guys try some on your own and then I'll guide you through after you've had a chance to give them a shot. So let's get right in and start the first example problem. So now let's do an example problem which actually has a three-part answer. First of all, let's see what we're dealing with. We have a chemical equation which is already balanced where we have 2 moles of aluminum bromide reacting with 3 moles of iron 2 sulfate, reacting to produce aluminum sulfate and iron 2 bromide. Now, this is already balanced, so let's take a look at what we're given. We've got 34 grams of aluminum bromide and 23 grams of iron 2 sulfate. Now, we first want to find the limiting reactant, but something to be aware of is that we're also looking to find the mass of iron bromide produced. Now, part of finding the limiting reactant, I told you, is going to be figuring out how much product each reactant could produce. Well, if we're trying to do that, why not already utilize the iron bromide? The reason for this is because we could have used the aluminum sulfate or the iron bromide, but we have to use the same product for each, so we're comparing apples to apples. So what we're going to do is to combine 2 parts of the answer into one, essentially, is we're going to go from grams of aluminum bromide straight into grams of iron bromide. And this is going to allow us to find the number of grams of iron bromide, which will help us answer the second part. So we're going to use stoichiometry to go from grams of aluminum bromide to grams of iron bromide. So with stoichiometry, we've converted from grams of aluminum bromide into grams of iron bromide. So let's make sure our units cancel first. They do. As a result, we have grams of iron bromide as the only unit remaining. We multiplied it across the top and divided it across the bottom, and we found that we had produced 41 grams of iron bromide, assuming that the 34 grams of aluminum bromide would be fully used. Now let's do the same thing with our 23 grams of iron 2 sulfate. We're going to convert to the same unit, grams of iron bromide. So as a result of our stoichiometry, we again want to make sure that all units cancel. They do. So we multiply across the top and divide across the bottom and find that we produce, with 23 grams of iron 2 sulfate, 33 grams of iron 2 bromide. We then compare the amounts of our product produced and see that we produced less iron bromide with our iron 2 sulfate, which means that it is our limiting reactant. But notice we already found the answer to the second part, which is how much iron bromide would actually be produced in the course of this reaction. We did that by doing the math all the way out to grams of iron bromide. So we can just simply answer that part now. Now the last part is challenging, because we need to figure out how much of our excess reactant remains at the end of this reaction. We now know that the aluminum bromide is our excess reactant. So now what we need to do is figure out how to go from what we have to figure out how much aluminum bromide remains after the reaction is complete. So let's take a look at how to do that. So for the final part of this, we need to figure out how much excess reactant is going to remain. We now know that the iron sulfate is our limiting reactant, which means aluminum bromide must be our excess reactant. In order to figure out how much excess reactant remains, we first need to figure out how much was used. Because we know we now produce 33 grams of our iron bromide, we're going to use that value to do stoichiometry, go back to figure out how much aluminum bromide was actually used in the course of this chemical reaction. So now, the stoichiometry, we want to make sure, again, units cancel. Which they do, telling us that we can multiply across the top and divide across the bottom, and we get the fact that 27.2 grams of aluminum bromide were used to create the 33 grams of iron bromide that we know were already produced in the course of the reaction. Now, we were given up front that we had 34 grams of our aluminum bromide to start. We know we now use 27.2 grams of it, which means that 6.8 grams remain. It's important at this point that not only do we track units in stoichiometry, but we're now tracking context of units as well. For instance, we have grams of aluminum bromide, grams of aluminum bromide, and grams of aluminum bromide. So I added in some context, initial, used, remaining, to make sure that when I'm looking for the answer, I know exactly what I'm looking for. And that is going to be the 6.8 grams of aluminum bromide which remain. Next, I'm going to have you guys try a problem very similar to this. Now you guys are going to try one of these very challenging practice problems on your own. We have 3 moles of calcium nitrate reacting with 2 moles of iron chloride to produce 2 moles of iron nitrate and 3 moles of calcium chloride. We have initially 16 grams of calcium nitrate and 15 grams of iron chloride. I need you guys to find what is the limiting reactant, what is the mass of the calcium chloride produced over the course of this chemical reaction, and finally, how much excess reactant remains after the reaction is complete. So you guys should pause the video, take a few minutes. If you get stuck or get to an answer, unpause the video and we'll work through it together. All right, now that you guys have had a few minutes to work on this, let's start by finding what is our limiting reactant. In order to figure out what our limiting reactant is, we're going to figure out how much product each of these can produce. We want to make sure we're comparing apples to apples, so we're only going to pick one product. Because of the fact that part 2 is asking for the mass of calcium chloride, let's just pick calcium chloride to find the mass of, because that's going to kill 2 birds with 1 stone. We're going to be able to find the answer to both part A and part B together. So we're going to go from grams of calcium nitrate into grams of calcium chloride first. Now, once we finish with finding the mass of the calcium chloride that can be produced, we find that from 16 grams of calcium nitrate, we can produce 11 grams of our calcium chloride. We need to do the same thing for 15 grams of iron chloride. So let's do that now. Now, as we can see, from 15 grams of our iron chloride, we're going to be able to produce 15 grams of calcium chloride. Now, we compare our 2 products. And we see that we produce less calcium chloride with our calcium nitrate than with our iron chloride. This means that calcium nitrate is our limiting reactant. And because we already solved for how much calcium chloride was produced, we already know that 11 grams of calcium chloride was produced as a result of this chemical reaction. The next step is challenging because we now need to find the mass of the excess remaining. So what I'm going to do is I'm going to erase the stoichiometry here, and then I'm going to show you how we solve for that component. So let's do that now. So now we find the amount of our excess reactant remaining. We've solved already that calcium nitrate's our limiting reactant, which means iron chloride is our excess. We also know that we produced 11 grams of calcium chloride as a result of this chemical reaction. What we're going to do to find how much iron chloride remains is we're going to start with the amount of calcium chloride that we produced. We're going to now use stoichiometry to go from grams of calcium chloride to grams of iron chloride. Now, as a result of this stoichiometry, what we're actually finding is how much iron chloride was used over the course of this chemical reaction to produce grams of calcium chloride. So we're going to use stoichiometry to get from here to here. So as a result of our stoichiometry, what we found is that we used 10.7 grams of iron chloride over the course of the reaction to produce 11 grams of calcium chloride. Now, where this comes into play is that we know we started with 15 grams of iron chloride. We then used 10.7 grams of it. Which means that we have 4.3 grams of iron chloride remaining. Now, a couple of things. First of all, if you were not able to track your units throughout this, you most likely made an error at some point during the course of this stoichiometry. Make sure you're very cautious and very aware as you're tracking your units. Finally, as we're using the same units, grams of iron chloride, and grams of iron chloride, my recommendation is that you include a unit of context, such as grams of iron chloride initial, grams of iron chloride used, and grams of iron chloride remaining. This way we know exactly what to report for our answer. So, as a result of our problem, we were number one, able to find the limiting reactant, calcium nitrate. We were then able to find the mass of the calcium chloride produced in the same exact step over the course of the chemical reaction. We know we produced 11 grams of calcium chloride. We then used that to go back and figure out how many grams of iron chloride were used, and then use that to figure out how many grams of iron chloride remain. This is a very challenging problem. So if you got lost or made any mistakes during the course of the problem, make sure you go back and understand where you made those mistakes so in the future you won't make them again. Alright, so that wraps up this video. Let's do a quick recap. We started by reminding you as to what the definition of a limiting and excess reactant are. Then what we did was we did some practice problems where I showed you how to do it. Then you did some practice by yourself. Alright, so leaving this video, remember, limiting reactant problems are some of the most common problems in chemistry because of the fact that in general, there's never going to be a real reaction that does not have a limiting reactant. Every realistic reaction in chemistry has a limiting reactant. Always remember to look for the problems when they have two amounts of reactants given. So if you see the amounts of two different reactants provided to you, you almost can be guaranteed it's going to be a limiting reactant problem. I'd like to thank Will Stairs and Trey Ursulo for writing the script, directing, filming, and editing this video. I hope you guys enjoyed it, and I'll see you in the next one.